Hi, my name is Lucas, and today I'll be presenting you the Beas Manufacturing features for the food industry. I'll be presenting you the software in a SQL database, so this is why you are seeing this layout here for Business One. But the functions that I'm going to show you are exactly the same for the HANA environment as well. In here in the background, I've added a few dashboards for you to know which kinds of information you can get from our system if you are using it in SQL, using our B1 app functions for dashboards, or if you are using SAP Business One in HANA. So I have a dashboard here that you can see the planned production for the day. So I have a list of all the operations planned for today. I also have an indicator here for my productivity per hour, and I can see how near or how far I am from my 10,000 parts per hour target. I can also see the statuses of my work orders in the current month, so I can see how much orders I have overdue, how much I have closed, how much I have planned, and so on. And I can also see a list of all my production that is currently overdue. So I'm sure that I'm not losing any orders on the shop floor. In the presentation of today, we are going to look at two examples. I'm opening up the function in which we can see all our item structures. So in here, I can search for the items I want to see. And the two examples that we are going to see in this presentation are the fish croquettes and the cooked chicken meat. The fish croquettes are manufactured using the raw materials listed in those blue lines in here. So we have in here the fish belly, the vegetables, flour, milk, seasoning, salt, and a plastic package. And those materials go through the processes of grinding and cooking. As for the grinding processes, we have a description that tells us that we are going to grind the fish meat. And for this operation, we have a group of resources. So instead of having only one machine linked to this operation, we have a group of 3 different machines that can perform the same operation. We have machine number 1, 2, and 3. But as you can see in here, those 3 machines have different operational costs. So I have one machine that costs me a total cost of 1 per minute, another one that costs me 1.44, and another one that costs me 2.15. And as it's most beneficial to me to use the machine that has the lowest cost per minute when I am running my production, what I have done in here is that I created an optimization sequence telling the system that I want to use machine number 3 first, as machine number 3 is the cheapest one. If I don't have enough capacity for machine number 3, then I'm going to use machine number 1 or machine number 2. Now, if I check my second operation, the cooking operation, I can see that while I am grinding the fish meat, I'll be cooking the vegetables. And we can see that those two operations will be running in parallel because we have those bars at the top and at the bottom of the 2 lines in here. So grinding and cooking will happen at the same time, will start at the same time, but we see that the cooking operation will last a bit more than the grinding operation. And the cooking operation that will be used for cooking the vegetables is directly linked to only one resource. In this case, we do not have alternative machines for doing this task. We have only one machine. Then after finishing those 2 operations in here, we are going through the processes of mixing, frying, and packing. For the frying operation, we also have something else. There is a parallel resource performing the task with the machine. So basically we have a frying machine, and as the resource is frying the products, an employee will be operating this resource. And in the end, we will have both the cost of the machine and the employee added to the product. For the frying operation, we also have a quality control inspection plan attached. It means that when I run this operation, I'm going to do a timely based inspection. For every 120 minutes of operation, I'm going to have one quality control order for checking some data of this operation. For example, the humidity and the temperature of the products that it is processing. And if I don't have this data collected, I will not be allowed to proceed in the production process. Now let's check our second example, the cooked chicken meat. For the cooked chicken meat, we have the raw materials listed in here, like the chicken meat, seasoning, salt, plastic package, and carton box. And those materials will go through the processes of mixing, vacuum packing, cooking, and final packing. Now, the mixing operation is also linked to a group of resources, as we can see in here. If I open it up, I can see that I have 3 machines to process this operation as well. And then the processes of vacuum packing until packing are linked to each other. And we can see this by this black number at the side of the green number. The green number represents an ID to each one of the positions. It is sequential, and the black number means that this operation is linked to another one, in this case, operation 40. So operations 20 and 30 are linked to operation 40. And it means that when I register times for operation 40, I will automatically register times for operation 20 and 30 as well. So I'm going to register the whole time for these 3 operations in operation 40, and Beas will split the times automatically for me. Now, for showing you this demonstration, I have created a forecast scenario in which I included my sales forecast for both items that I showed you before. So, for example, for the fish croquettes, we have those forecasts for each one of those weeks. And for the cooked chicken meat, we have these forecasts for each one of the weeks. We can use the same forecast scenario for creating, for example, a master production schedule in which we define the quantities that we want to produce day by day, week by week, or month by month. Here I have also some examples of monthly forecasts and daily forecasts. And we can include the quantities that we wish to produce in these date ranges. Now, if I come in here and open the MRP wizard, you can see that I have different scenarios for running the MRP calculation. Our solution enables you to create as much scenarios as you want for running the MRP calculations. Each one of the scenarios can hold its own settings. For example, here I can select which forecasts that I want to consider in the MRP calculation, which system transactions I want to see when running the MRP calculation. For example, if I want to see sales orders or not, if I want to consider the work orders or not. And then we can also select which warehouses we want to consider in the MRP calculation. After we have those definitions, we can click on this button to run the MRP calculation. And then the MRP will look into all the transactions that we have defined in the MRP scenario to calculate how much items we need to purchase and how much items we need to produce. This result will be the result of our MRP1. That is one of the results that the MRP can give you. The second result is the MRP2. In the MRP2, we can see a graphic showing the estimated occupation of the production resources, considering the open sales orders, open forecasts, and already created work orders. Now the MRP has finished its calculation, and when I click on this button called Resources, it will open the MRP2 for me. In here I can select for which resource I want to check the occupation. So I could, for example, check how occupied will be my employee number 1. And then I can see bars with different colors in this graphic. The color blue represents work orders. This is what I see in production. And clicking in here, I can see which work orders are scheduled for this person in each one of the days that I can see in this timeline in here. Now, in here, I also have a yellow color, and the yellow color means forecasts. And clicking in here, I can see that the forecast that I created for the fish croquettes is occupying this person's capacity in this date listed in here. And I can also have a third color that is sales order, and I would see the sales orders bar in green. And this will mean that I have sales order that I need to produce that will be occupying my resource capacity in a specific day, week, or month. Here we have three buttons for selecting the time intervals that we want to see. Now I'm seeing the occupation day by day, but I could also see it week by week. And we can see that we have some weeks in which we are not 100% occupied, but we do have some weeks in which we have a big occupation for this resource. And I can also see it month by month. And then I can see how occupied will be this resource in this time range. This also enables you to calculate if you have enough production capacity for the forecast that you have created. Imagine that you have forecasted your sales from the beginning until the end of the year. You can run the MRP calculation to see how occupied your production resources will be when fulfilling your forecasts and check if you have months in which you have more than 100% occupation or not. And this could mean that you need to increase your production capacity to satisfy your forecasts. Now clicking in order recommendation, you can open up the MRP1. Here we have the recommendations of the MRP1. We can see the recommendations in two different icons. We can see the blue icon for the purchase materials and the folder icon for the production materials. And in these columns called CW, that are calendar weeks, we can see what are our requirements for each one of the weeks that we have listed in here. So we can see that for the next week, we are going to require to produce 200 units of fish croquettes and 400 units of cooked chicken meat. Then in the next 2 weeks, I don't need to produce anything. And then 1 week after, we have more quantities to produce for fish croquettes and cooked chicken meat. And these are the requirements for each one of the raw materials that we are going to need to produce the two items listed in here. Something else that we can do is to check how much it will cost us to produce the items. For example, I want to check what is the cost of producing the fish croquettes. And I can do this by looking at its production structure. Inside the item master data, we have two tabs in here, one for the bill of materials. That includes all the materials you are going to use in each recipe. And we have another tab for the routing, including all the processes that we must perform to produce this item. And to check how much it will cost for us to manufacture this item, we can come here into the calculation tab and run a calculation. When we run this calculation, the system will bring all the materials from this item bill of materials, including all the costs for each one of the materials and all the processes and the times and costs for each one of the processes. And then I can see a detail in here of what is my direct material costs, what's my labor costs, and what's my total production costs. Based on that, I can even sum some more costs, for example, transportation costs, commission costs, profit margins, discount margins, to know what should be my ideal sales price for this item. And I can do this for each one of my items, and I can also do this in a batch. It means that I can massively calculate the costs and prices for each one of my produced items. And I could even transfer this calculated price into a price list. Now coming back into the MRP, we need to calculate for a specific range of days how much we need to purchase of materials and how much we need to produce. We can do this in a very simple way by clicking in Mode, clicking on pre-assign, and then determining for how many days we need to purchase or produce materials. Let's say that I want to purchase and produce materials for the next 21 days. I can type in 21 in here, click on pre-assign, and then as I have selected purchase, the system will only calculate the materials that I do need to purchase in the next 21 days. And in here I can see the quantities that I require for the next 21 days. It is, of course, not considering the quantities that I need for the future for more than 21 days, only for the 21 days that I have specified. As I have bought this item before, I can see the current price based on my last purchase price, and I also have a predefined supplier for those items. And then I can easily convert all those requirements into purchase orders by clicking in the button Purchase Request. Then Beas will create a purchase request for me. And when I open up the purchase request, I can just click on the button Create Purchase Order to transform these 3 requests into a single purchase order. I could also create a purchase quotation if I wish to quote prices with different vendors. Then I could click in here, duplicate my purchase quotations, change the vendors, and run a report that Business One has, that is the purchase quotation comparison report, that enables you to see which vendors offer the lowest prices, which vendors can deliver you most quantities, and which vendors can deliver you the items earlier. Now I'm going to create a purchase orders for those 3 materials. Okay. And then I'm going to calculate how much I need to produce for the next 21 days as well. And I'll click on the pre-assign button, select make, and then select 21 days. Then I know that I need to produce these amounts of products. And I can convert these requirements into work orders by clicking on production. And then transforming those 2 requirements into orders. Now Beas is creating the work orders for me. It is done now. And if I come here into the production model and select work orders, I can see that I have 2 work orders created for the items that the MRP recommended us to produce. And remember that we had 1 requirement for 650 fish croquettes and 1 requirement for 700 units of cooked chicken meat. But here in our production orders, we do have 2 lines for fish croquettes and 2 lines for cooked chicken meat. This is because I have defined optimum lot sizes for production. If I come into the item master data, I can see that I have defined a lot size of 350. This means that my work orders will be broken into units of 350. So since I had 650, I ended up with 1 production position of 350, that is my optimum batch, and another one for 300. We could, of course, determine multiples that meets our optimum batch as well. So instead of having 1 of 350, another one for 300, I could have 2 for 350 if I had a multiple quantity of 350. And then in here, I can see that I have 2 production positions of 350, as if I come here into this item master data, I can see that I have defined, again, an optimum batch size of 350. Okay, now we have our purchase documents, we have our production documents. Let's check when we are going to be able to produce these items considering our resources capacities and also our material availability. For that, we can come here into our capacity planning module and open our APS function. The APS stands for Advanced Planning and Scheduling and is a function that we have in the system for scheduling the production considering the resources, capacities, and material availabilities. This is also based on scenarios. This means that you can create as many scenarios as you want for APS by clicking in Use Scheduling. And clicking in Edit Scheduling, I can see my current parameters for this scenario. In here, we can filter which, let's say, which classifications of items we want to schedule in this specific scenario. For example, groups of materials, we could even filter by priority. Let's say that we want only to see critical work orders in this APS scenario, or only items belonging to a certain group. Then we can select which resources we want to see in this planning scenario. Let me select only this group of resources in here. Let me uncheck this. And then we can define which types of calculations we want APS to perform. Basically, we can do 2 types of calculations. We can do a forward calculation. That is a calculation that defines to you what are the earliest dates you can finish production using your production capacity as maximum as possible. And then we have another type of scheduling that is the backward scheduling that will define for you what is the latest date you can start to produce the item to deliver on the date that the customer requires. So you can select the possible types of calculations and then view the recommendations for APS. Here are the orders that we need to make. So we have 2 production positions for item PA166 and 2 production positions for item PA170. Here in the material group, you can see that I have an identification for the type of the material that each one of those orders is. So we have 2 orders for fish and 2 orders for kitchen. Let's say that every time we change the type of material, we need to perform cleaning on the machine. So if we can group the materials based on this common characteristic, this would make the process much easier, faster, and not requiring as many setups. So let's say that when we open up this report, we have this situation in here. We have fish, chicken, fish, chicken. This means that I would produce fish, then clean the machine to produce chicken, clean the machine to produce fish, and clean the machine to produce chicken again. If I want to optimize this process, I can just right-click the column and sort the material based on the characteristic. And this would make me to produce chicken, and then perform just one cleaning to change to fish and produce fish again. And this optimizes the amount of set types that we have to perform and the times wasted on setting up the resource. Now, after we have sorted the orders in here, we can click on calculate and APS will perform the calculation to optimize the production and define the production dates for each one of the orders. After we finish the calculation, we can see the start and end dates for each one of those orders. And then we can see based on the color that we see on the end column if we are able to meet the delivery date or not. So here we have the delivery date, here we have the date to end production, and as the date to end production is superior to the delivery date, we see the lines in red. And here we have 2 very important columns that are material OK and material on warehouse. Material on warehouse means that we have all the materials on stock to start producing the items right away. Material OK means that even though we might not have all the materials on warehouse, we do have purchase orders to cover all our material requirements. If we want to know which materials we are missing, we can just click here on report and select shortage. This shows us which materials we are missing for being able to do this production process. So here we see that we are missing seasonings, and the seasonings is set. I have a purchase order to cover in this seasonings requirement, and this purchase order is set to be received at November 7th of the year 2018. If, however, I update this the delivery date of this document, because of course I will not be able to receive the items in this date, if I change it to the future, let's say April 10th of 2019, and then I recalculate APS, now I see a different end date for production. I see that I am only able to start and finish production by April 10th. For the first one, and for the second one, I'm only able to finish by April 11th. This is because if I come here on the shortage, because I am missing seasonings that I require for the production process. And I can do the same analysis for the fish items by coming into shortage and see which materials I am missing. So I can see that I am missing these 3 materials and they are set to be received by April 9th. And I can only finish the orders by April 9th because I need these materials to be able to finish production. I can start the production tomorrow, however, because I have some materials on stock that I require for the first operations. For example, if I check my orders on a graphic, I can see that for the fish croquettes, I have a grinding operation that will consume the fish meat, and I can do the grinding operation tomorrow, but I cannot proceed with the production process tomorrow. I need to wait until I have the remaining materials. Of course, this is happening because I have set to do the production scheduling forward. I could, and on the other hand, do it backwards. And then when I schedule the order backwards, all the production operations will be together to the next one. And so I will not have any delays, even though the order might get delayed because I am missing materials. Now let's receive the materials on stock and see the impacts of this on the APS calculation. For receiving the materials on stock, I'm going to open our terminal solution here in Factory Data Capture Terminal. And as you can see, we have a set of different operations that we can perform on the terminal. We have, for example, login, logoff work order that enables us to register time for the production operations. We have those two other options for registering times are the pull report and the quick input that enables us to handle times for multiple work orders at the same time. We have arriving and leaving that are linked to our attendance module for controlling which employees are present in the factory in a specific time. Then we can perform backflushing functions. We have login and logoff interruptions to register that a machine is stopped by any reason, like for example, if the machine is broke or if the machine is down for maintenance. If we do create an interruption for a specific resource, this interruption can trigger a maintenance order for me. So if I select that this specific machine is broke, I need the technician team to go and perform corrective maintenance, and this automatically triggers the maintenance plan for corrective maintenance for that resource. We have this linked to our industrial maintenance module. Then in this module, we can define plans for corrective maintenance, but also for preventive maintenance based on maintenance calendars and for predictive maintenance based on production counters. Then the technician team can come in here and see all the maintenance orders that they have to perform for the resources and also the maintenance orders that are planned for the future. Then we can consume materials for production, receive finished goods. We can allocate materials for production. This means that we can reserve raw materials for a specific work order. We can receive purchase goods. That's exactly what we are going to do now. We can perform inventory stock taken and count our inventory. We can perform quality control inspections and other stock transactions, like, for example, stock transfer. We can also perform issues and receipts and so on. So clicking here on the collective good receipt, we can select which purchase order that we want to receive. I'm going to receive this one. Then we can fill in the quantities that we are receiving and to which warehouse we want to receive the materials. This material is set to the quality control warehouse. And if I do receive the materials in here, it means that I'm going to inspect the materials before releasing it for production use. I'm going to receive this one for quality control. Now I have to receive flour. And let's say that instead of receiving flour for the quality control warehouse, I'm going to set it to a warehouse in which I have bin locations control, like this one. When I do that, I can see the layout of my warehouse, including my storage in areas that are the squares that we can see in here. And clicking on each one of them, we can see the specific bin locations that we have inside it. And we can click on each one of them to select the bin location in which we want to allocate the products. If we select a different storage in area, then we can see a different layout, because the layouts that we can see in here can fit exactly what you have on your factory. Now let me instead select a warehouse in which I don't have bin locations, like this one, and then fill in the quantity of my last item, there is the milk, and receive the materials. Now, if I close this and open the quality control orders function, I can see that I have a quality control order for inspecting the vegetables, that are the items that I allocated into the quality control warehouse. For this example, I have one sample. The quantities of samples and the number of measurements that we have to perform are linked to what we call quality control inspection plan, in which we define everything that we need to inspect for a certain item. And here we can see that for this sample, I need to do 3 inspections. I have to inspect the item's weight, the packaging conditions, and the item's appearance. For the weight, I have a minimum and maximum allowed values. And if I do input a value that is not within the allowed values range, then Beas automatically set it as not released, and I can configure it to don't allow me to manually release this item if the value is not between the values I want to accept. On the other hand, if the value is between the values we can accept, then it gets released. Now I'm going to release the packaging and the appearance. Now I have set the sample to be automatically released, and I have also set my quality control order to be automatically released as when I finish releasing the samples. Now after we finish the inspection, we have to transfer the items to another warehouse. So the items are currently in the quality control warehouse, and this warehouse is blocked for production issues. And then I'm going to move the items to my released goods warehouse by creating a stock transfer. I can click here and I'll pre-assign for the system to calculate how many items I need to transfer, and then I can transfer the items into my released goods warehouse. Now I also set my quality control order to be automatically closed as soon as I transfer the items. And then I have all the materials I need on stock. Now let me just close the terminal, come back into SAP, and if I recalculate APS, then I can see that I do have all the materials on stock to finish this order on time, as I don't have any shortage for it anymore. If I check this other one, I see that I'm missing the seasonings. The seasonings were linked to a different purchase document, for which I have changed the date of receipt to April 10th. This is why I am only able to finish this by April 11th. Now, before starting production, I might want to check if all my materials are valid. It means that they have not expired, considering the expiry date set to the batches. We have a special function for doing that. There is the batches to be verified function. Using it, I can ask the system to test if the materials are not going to expire within a certain number of days. Let's say that I want to block all the batches that are going to expire within the next 15 days. So I add 15 days in here and click on OK. After I do that, the system will perform a verification for all the batches that I have and will automatically block all the batches that are going to expire within the next 15 days. And now it is just loading the result for me. And this is the result that I have. So all the batches that are going to expire within the next 15 days got automatically blocked. And I can see that they are blocked because the color set to the batch code is red. Here I can see the expiry date. So for example, this one is blocked as it has an expiry date that is in the past. So it means that this one already expired, and if the expiry date is in the future but within the next 15 days, the batch gets blocked as well, like this one. Now here on the APS, there is something else that we can do. There is to view in a timeline all the operations that we need to perform on the shop floor, and for that we can click on the Gantt chart. The Gantt chart will show us when we are able to start and finish each one of the production operations we have to perform. Remember that the operations of grinding and cooking were set to parallel, and so they are all set to end at the same time. Then after that, we have 3 more operations that are in sequence. And remember that for the grinding operation, we had 3 different resources that could process it. And if you click here in resource and select resources, we can see from the 3 different resources that we have, which one was selected for this specific operation, when we can see that this operation was set to mill number 3. That was the resource with the lowest operational cost. Now let's go to the production execution part. We can open the work orders from here. And here are the work orders that we need to perform. Let's start by producing the cooked chicken meat. I'm going to produce a position 10. I will print the work order by clicking on this button in here. Now this is our layout for the printed work order. We can see a list of all the materials that we need to consume, and then in here we can see all the operations that we have to perform, and we see a barcode for each one of the operation. This allows us to start and finish the operations on the terminal. And in here we also have a barcode for the work order itself that allows us to perform material transactions for this work order, like reserving materials. Now let's go into the terminal again. And from the terminal, we can log in into a specific production position. We can just read the barcode that we have in here using a barcode reading device. And clicking login to start the operation. Now we are connected to that operation. This means that we are currently working on it. And if you just want to know in which operations the shop floor employees are working on right now, we can come into Business One and then come into our production reports and open a report called Production Improvement. Now we can get a list of all the open work orders that we have, and we can see a status of all its production operations. So we see the orders here in this list, and on the columns that we have in here, we see all the operations that we have to perform. Now this is the order that we are currently working on, the cooked chicken meat order, position number 10, and then for the first operation we see a red color. The red color means that someone is currently working on this operation right now on the shop floor. All the operations that we see in gray means that they have not been started or registered yet. The ones we see in blue, like this one, means that someone has started and finished the operation partially, and then more time receipts will be created for the same operation. And if you see it in green, this means that someone has started and finished this operation completely, and no more transactions will be done for this operation. Now, when I come back to the terminal, let me just close this, and click in log off work order, we can just read the barcode again in here. And then Beas will calculate the duration of the time received, the time between started and finishing the time received. This time was calculated as 2 minutes. If I want, I can block the field using a system setting so no one is able to change the duration calculated by Beas. But as this is a demonstration, I have left this field open, and I'm going to increase the time just for having a greater cost in the product evaluation. And I'm going to set this operation as complete. If I want, I can change the quantities and do a partial receipt as well. And as we complete the operation, if we do have materials to consume linked to that operation, this screen will pop up for us, allowing us to select the batches of the materials that we want to consume. For example, we have a requirement for consuming chicken meat, and we do have one batch of chicken meat available. For consuming this specific batch of chicken meat, I could just double click on it, or I could read the barcode of the item that I am consuming. I can just read the barcode in this specific field, and then Beas will select the item for me. If I happen to read the barcode of another item that I should not consume for this material position, or a barcode that does not exist, like this one, then it just tells me that the entry was not found, and it doesn't let me to consume this non-existing or linked to other material batch. If I want to consume more or less than planned, this is very easy. Now the planned quantity was 350 and this is what the system selects if I just double click in here. But let's say that I have consumed 15 kilograms more. I can just add an additional 15 kilograms line in here. Or I could consume less than planned by doing this. Based on the icons that we see in here, we can see if we are consuming more or less than we have planned. If I select exactly the quantity that I have planned, then the icon turns green. If I select more, then the icon turns out to have a red top on it. And if I select less, then the icon becomes gray. How we confirm the consumptions? And then when I come back into Beas and refresh the work order, this is what we see. We see that we have consumed the first 3 materials and we have registered the first time. If I open up this, I can see the material issues and I can see the time received. Now remember that those 3 operations in here are linked to each other. So it means that when we register the last operation, the operations 2 and 3 will be automatically registered as well. So I'm going back to the terminal. I'm going to read the barcode of my last operation. That is this one. Start it. And then I'm going to finish it. In here, I'm going to have the time of the 3 operations, not only the last operation. So I'm going to add 280 minutes. And then when I complete this last operation, Beas will open up the screen for me to consume the materials. So I have to consume those 2 items in here. And when I come back into Beas and refresh it here, then I can see that I have all those operations completed and I do have a material receipt with a batch number. And clicking on the batch number, I can see the tracing report, including all the batches that I have consumed to manufacture this item. This is the batch that I have assigned to my finished product, and I can see that I also have a quality control order to inspect it as well. And those are the batches of the materials that I have consumed. And clicking on each one of them, I can see the transactions that happened to them. For example, this specific batch, I can see that I have purchased from this vendor. This is the quantity that I have purchased, and this is the analysis that I did when I purchased the batch. If I want to check the quality control parameters for this specific raw material and I purchased it, I can see it here. So I can open up the samples and I can see on the samples which analysis that I have done. And this is the quality control order that I have for my finished product. Clicking in here, I can see that I have one sample with 4 tests. I have to check its appearance. I have to check the item's dimensions. Of course, we can define which kind of test we want to do based on the product characteristics. Then I'm going to check the item's weight. I have set the sample to be automatically released, but I have not set the quality control order to be automatically released, neither the batch. So you can see that the batch is in red. If I try to release the batch manually without releasing the quality control order, I get an error. The same I get when I try to transfer the items from the quality control warehouse into my release goods warehouse, because I cannot release the item until I have released the quality control order. And I have set in my quality control inspection plan that I do need a special password for releasing the goods. This is not the same password as the user password. This is a specific password for quality control, and without this, I may not be able to release goods. This is of course optional. It's not mandatory to have this password for releasing goods, but it do create an additional layer of security for preventing unauthorized persons from releasing goods from quality control. After I input the password, then it releases the order, and when I have the order released, I can release the batch, then the batch turns green, and I can transfer the item from the quality control and into the released goods warehouse. And then I can finish the quality control process. Double clicking in here, I can see the product valuation by coming here into journal, and I can see how much I have of journal entries created for this specific production process. I can also compare the costs, the planned and actual cost by using the product costing analysis. And coming here into planned actual calculation, I can see the comparisons between the material actual and planned costs and the production actual and planned costs. Here I can see that my actual production costs were much higher than my planned production costs because I had more operational costs than I was planning. Now let's produce the fish croquettes. Remember that for the fish croquettes, for the frying operation, we have a quality control order in which we have to read in-process data for quality control for every 120 minutes of operation. As we have 157, then we need to take one sample from the process to analyze. Then I'm going to print this work order. Here I have the list of items. Here I have the operations. For the operations, we can also add work instructions. In this case, I have added all the materials that I have to consume in each one of the operations. So first, I'm going to grind the fish meat and cook the vegetables. After that, I'm going to mix the fish meat, vegetables, flour, milk, seasonings, and salt, and go to the last processes. Now, let's come into the terminal and read the barcodes of the operations. To report them, I'm going to read the first barcode, that is this one. This is the barcode for grinding the fish meat. I'm going to log in and log off this first operation. The system will count the time for me. Let me just add a bigger time and complete this operation. Since I have to consume raw materials for this operation, then this screen pops up for me. This screen is not mandatory. I can configure different ways of consuming materials. I can have the materials being automatically consumed without the screen popping up, or I could even consume the materials before starting the production process, and so the screen doesn't pop up at all because the materials are already consumed. Or I can have this popping up for the operator to input how much materials it has consumed. Okay, now I have finished my first operation. I'm going to start the second one. And if I don't want to read the barcodes, let's say that the customer is operating in a paperless environment, we could scroll down this list and select the next operation from here. So in here I can see the number of the work order, the number of the position, and number of the production position, the operation, and select which one we want to start. So let's say that we want to cook the vegetables. Here we have the operation for cooking the vegetables. This is for production number 20. Let me just go down. Okay, here I have it. Here I have work order 2668, production position 10, operation 20, and this is exactly the same one that I have in here. So instead of capturing the barcode using a barcode reader, we can, in a paperless environment, just select the operation in this list. And after we finish, we can just click here and select the operation you want to finish. And then the system will calculate the time as well. And I'm going to complete this operation. It had calculated 0 because not even 1 minute passed between starting and finishing. Now I'm going to consume the vegetables. And when I come back into SAP and refresh the work order, we can see that we have 2 materials consumed and we have times registered for the 2 operations. Now we still have to register 3 more operations. I'm going to register the next 2 ones. Here I have the next one. I'm going to start it and finish it. I have more materials to consume in this operation. Okay, now the next one. Start it, finish it. And this is the operation in which I need to capture data from the machine while I am processing it. So when I complete it, the system will automatically open up the screen for me to capture the quality control data. If I don't capture quality control data and I refresh this in here, I'll see that the quality control order is still open. Like in this case, I can open up this operation for the frying operation. And then I can see that the quality control order is still open. The analysis have not been done yet. And then if I try to register times for the last operation, that is the packing operation, I'm going to get an error. This error tells me that the quality assurance in the previous operation is not okay, so I cannot register times for the operation I want to. Because first I need to release the quality control analysis, and only when the quality control analysis is released, I can proceed with the production process. I can come here into quality control orders. I'm going to see the in-process inspection, and then from here I can capture the data that I need to. And when I have this analysis finished, I can log in into my last operation. And it will not show me any error. Now I can log off by selecting it here in this list and complete it. When I complete, I can have the system automatically booking the finished goods for me. It is booking the goods for me now. Okay. When I come here into the system and refresh the order, I have it completed. So this is what I was planning to show in this food industry demonstration.